All right, we are moving into 2.3, which is called the positive-negative connection. It says addition and subtraction are related to each other in ways that can help you solve problems. If you know that 5 plus -8 is -3, how can this help you find the answer to 5 minus 8? Examine these two expressions and think about how they are alike and how they are different. A plus negative B and A minus B. What is the difference? How are they the same? I think the rest of it is just information. So, it says use your ideas about addition and subtraction of integers to explore the relationship between these two operations. So, part A. The chipboard in the picture below shows a value of +5. There are two possible moves, one addition and one subtraction, that would change the value on the board to +2. How would you complete the number sentences to represent the, what does it say? To represent each move. So this is 1A. So it says +5 plus some number equals +2, and +5 minus some number equals +2. So this is a matter of like the black chips and red chips, and then just subtracting. So if we have the 5, I should probably do colors for this one, I feel, so that you can see what we're talking about. So if we have 1, 2, 3, 4, 5 black chips, and we only have 2 left over now, what could we put here to get rid of 2 of these? Well, remember, if we add a red chip, it cancels out like this, right? They cancel out. So then I'll put another one here. So now we have 3, but I need 2. So I'm going to put one more here, and it's kind of getting a little cramped. So altogether, if we put 3 red chips, we will cancel out 3 of the black chips, and there will only be 2 left over. So the answer here is going to be 3 red chips. But over here, if we have, because we're adding red chips, right? That's what's happening here. We're adding red chips. But if we are subtracting now. We are taking away. So if we take away 3 black chips, we have 2 left over. So it's now +5 minus +3. So that's the difference that they want you to see. Part B says, describe how these moves are different on the chipboard. So in the first one, yes, you need to copy this down. We are adding red chips to cancel. Oh, that's not how you spell that. I can spell. You cancel out one. Oh, wait, no. We are adding red chips to cancel out one black chip for every red chip added, which is the opposites situation. What was that called in the first? What do they call that? Additive inverses. Opposites and additive. That's still not how you spell that. Man, what is wrong with me today? I'm having problems. Additive inverses. Okay. Whereas in the second, we are removing black chips from the board. So again, this is where that comes in, where I said that the plus and the minus here, these are actions. These tell you to do something. This says add something and this says take something away, right? But then the negative and the positive signs here, these describe the number. So here this says we are going to add 3 red chips. And then this says we are going to take away 3 black chips. That's the difference. But the whole point is that you get the same answer. Yeah, I'm on the wrong page. To A. How would you complete the number of sentences below to change the value on the board to positive 8? So now we have positive 5 plus some number equals positive 8, and positive 5 minus some number equals positive 8. Now we have to get creative here, because this is going to be a little more outside of the box type thinking. All right, so let me get myself situated here. I'm having technical difficulties. Why are you not the right size? Ruh-roh. Okay, I fixed it. All right, so for this one, what would we have to do to get, instead of 5 black chips, to now have 1, 2, 3, 4, 5, 6, 7, 8. Well, that's not even, but that's okay. We need to add something here. So I would say the natural inclination would be to add 3 black chips for a total of 8. So we are adding 3 black chips. Here, now we have to get a little fancy, I would say, because we are taking away something and then getting positive 8. So I'm trying to think of what the best way would be for you to visualize this. Clearly, we have to take something away, but we can't take away any of this because that would make us go backwards, not forwards to 8, which means that we're going to have to be taking away red chips. We're going to have to add in some red chips. So if we were to, man, this is a hard one to show in like a picture. If we were to do what we did up here, we would be having, like if we added these here, we would have to undo. Oh man, I don't know how to explain this picture. But remember how we said that they undo each other, this action? There has to be a better way to explain this picture, and I, for whatever reason, cannot come up with what it is. Because they would undo each other, right? Like we did up there, but that was adding them. But we're supposed to be, oh, okay, I got it. If each one has its own red chip, and then we were to cancel out 3 of them visually, does that, I don't know if that makes sense still, like at all. Probably not. That probably still does. I got so excited. I'll have to rethink this picture and like come up with something better to show you. But remember that we have our ghostly one right here, and 5, and then if you were to multiply these, -1 times -3 would be a +3, so it would be 5 plus 3, which would be 8. So I wonder if I could try, just so you know, this is problem solving in math, which for you, you're probably like, I understand nothing. But I wonder if I just added on 3 couples like this, 3 sets. You see what I'm saying? 3 sets that cancel each other out. But then took away the 3. Oh yeah, I think that makes more sense to me. I don't know if it makes more sense to you, but this makes more sense visually to me. If I was to add 3 sets that would equal 0, and then take away the 3 red chips, I'm left with 3 more. I think this is probably a more visually understandable picture. It's not really important, I guess, unless you're very visual. If you understand this part, then you're fine. But if you do need the picture, I think maybe that is more relevant. But it's important because you have to add the black chips too. So you would have to add 3 sets of the additive inverses and then get rid of the 3 negative chips. So part B says, describe how these moves are different on the chipboard. I would say first is adding black chips, and second is adding additive inverses. To have something to take away, to have something to take away. Like you basically had to add more of these in order to have something to take away. I feel like this is like, obviously this is the hardest one to understand. It's because of this situation here. Part B, complete each number sentence. So remember, if we have two statements side by side and there's an equal sign in between, these need to simplify down to the same number to make it true. So if this would be positive 1, this would need to, whatever this is, would need to change this into a positive 1 as well. So 5 minus what number would equal positive 1? It would be positive 4. B is so this would be positive 9. And then 5 minus some number would need to be positive 9. Again, we're in this same situation where this number is going to be, we're having to do this situation because we're ending up with a bigger answer. So it's going to be basically however many additive inverses you would have to add, which would be 4. And then you would have to take away the 4 red chips like we did here. I really hope that this makes sense. I'll have to do some research and see if there's a different way to do that. I've never tried to draw that before. -7 plus -2 and -7 minus some number. So this would turn out to be -9. So this needs to also be -9. So -7 minus what number would be -9? It would just be positive 2. Because you're going backwards, right, on the number line. And then we have -7 plus positive 2 equals -7 minus some number. So this time we're going towards positive land on the other side. So this one is going to be -5. And then -7 minus some number, you need to end up with -5, which is closer to 0. So this is going to have to be, you have to have that negative to counteract, right? And then it's going to be the same number of bunny hops. And then number 2, B2, says, what patterns do you see from part 1 that can help you restate any addition problems as equivalent subtraction problem? So basically, if you just flip-flop the sign, I don't know if you guys noticed that. You just flip-flop the sign. So you can say something like you swap the positive negative sign. Yes. So tomorrow we will continue with part C.